Hey kids, in today's video we're going to review whole number place value. So our first skill that we talked about was how to read a large number. Remember, we read large numbers based on those sets of 3 digits called periods. So if I look at this 9-digit number, I know the first 3 digits are in the millions period, the second set of 3 digits are in the thousands period, and then that last set of 3 digits are in the ones period. So if I can read those digits, 734, I know I can say 734 million. My second set of 3 digits says 890,000. And then my last set of digits says 603. We don't say the name of the ones period, so I can read this as 734,890,603. Okay, we also talked about how to write numbers using both standard form and word form. Remember, standard form is written using digits. Word form, you write down exactly what you'd say out loud, but you write it down in words. So here we've been given word form, 800,088,008, and we're trying to write that in standard form. So again, if we think about the periods, I know I've got 3 periods here, the millions, the thousands, and the ones, and I can write the digits that go in each of those periods. In the millions period, I've got 800. So if I write my digits to express 800, I can put a comma to show that that's in the millions period. In the thousands period, I need to write the number 88. Well, I know the thousands period has the 100,000s, the 10,000s, and the 1,000s. So I need a placeholder 0 so that my digits express 88. It's 88,000, so I'm going to put the comma to show my place value. And then in the ones period, I have to express just the number 8. So I know I need a placeholder in the hundreds place and in the tens place so that that set of 3 digits just reads 8. So my number is 800,088,008. We talked a lot about how the value of a digit is determined by the place that it's in. We know the place is where the digit is located in the number, and the value is how much it's worth. So in this example, 9,340,198, the digit 3 is located in the hundred thousands place. Because it's in the hundred thousands place, it has a value of 300,000. Expanded form is another way that we can write numbers, and we know with expanded form, we're writing the value of each digit. So we're going to break this number apart, show the value of each digit, and add those values back together. So in 60,232,507, the 6 is worth 60 million. That's its value. The 0 is in the millions place, but it has a value of 0, so we're not going to include that in our expanded form. We'll move on to the 2 in the hundred thousands place. It has a value of 200,000. We'll add that to the value of the 3, add that to the value of the 2, add the value of the 5. The 0 in the tens place we know has a value of 0, so we'll finally add in the value of that 7. So our number in expanded form shows the value of each of the digits. We talked about another version of expanded form as well that we called super duper expanded form. And we said that super duper expanded form takes expanded form and kind of stretches that apart even further. It doesn't say just the value of each digit, it shows how you knew that value. So we know the value is determined by the place. So if I look at this number, 635,127, and I'm looking at that first digit, the 6, well, we know it has a value of 600,000 because it's a 6 in the hundred thousands place. So to write the value of that 6 in super duper expanded form, we write the digit multiplied by the place that it's in. Add that to the value of the 3. It's a 3 in the 10,000s place, so we can express that as 3 times 10,000. Add the value of the 5, 5 times 1,000. Add that to the value of the 1. It's in the hundreds place, so we write 1 times 100. The 2 is worth 20 because it's a 2 in the tens place, 2 groups of 10. And then the 7 in the ones place we can just express with 7 times 1. So remember, for super duper expanded form, inside your parentheses, you're showing the value of each digit by multiplying the digit by the place that it's in, and then you're adding those values back together. We talked about using place value to compare large numbers. Remember, when you're comparing numbers, you always want to look at the greatest place value spot first. If the digit in that place value spot is the same, you move on to the digit in the next greatest place value spot. So in this pair of numbers, I know I can use the 10,000s place to determine my inequality. And I know that 405,870 is less than 450,870. We also talked about how to put large numbers in order. Remember, you really have to pay attention to what you're being asked to do. Here we're ordering the numbers from greatest to least. So we have to decide which is the largest number. That's going to go first. The number with the smallest value is going to go last. If I look at these numbers and I look at the digit in their greatest place value spot, I see that the first two numbers start in the 100,000s place, but my last number starts in the 10,000s place. So I know right away that number is going to be or have the smallest value because it has a 0 in the 100,000s place. So if you make sure you're comparing the same place value spot, this comparison becomes very easy to do. 324,688 is greater than 246,880, which is greater than 32,468. The digits in the 100,000s place determine this comparison. We also talked a lot about how to round numbers. And remember, you can round numbers to the greatest place, or you might at times be told which place to round to. So for this number, I want to round it to the thousands place. So I have to find the digit in the thousands place. That 4 I know is worth 4,000. So my number is either going to stay at 34,000, or I'm going to round it up to the next greatest thousand, 35,000. All the numbers before your rounding place are going to stay the same. All the numbers after your rounding place are going to turn to zeros. So how do we determine if we keep our number the same or round it up to the next greatest thousand? We look at the digit in the next place, next to your rounding place. So here that's the 5 in the hundreds place. If your number is 5 or higher, you're going to round up. If your number is 4 or lower, you're going to stay at that same value for your rounding digit. So here I'm at a 5. I know that 500 is more than halfway to the next thousand. So 34,567 is closer to 35,000. If I round it to the thousands place, it rounds to 35,000. We used rounding a lot when we were estimating, and we talked about estimating for all 4 of our different operations. When we estimate sums, we follow regular rounding rules and then do that easy place value math in our head. So the regular rounding rules say we should round to the greatest place unless we're told otherwise. That's what's going to give us the easiest number to work with. So 1,689, I know is going to round up to 2,000 because of the digit in the hundreds place. 3,721, I know it's between 3,000 and 4,000. It's also going to round up because of the digit in the hundreds place. So once you've done your rounding, your calculation should be really easy to do. Here I'm just adding together 2,000 plus 4,000. Using place value, I know that my answer is 6,000. So if you think back to your original problem, the answer to 1,689 plus 3,721 should be close to our estimate, not exact. We rounded both of our numbers up, so we know our estimate's actually going to be a little bit high. We talked about estimating with differences, estimating with subtraction. The same as with addition, you follow regular rounding rules. So round your numbers to their greatest place and then do that easy place value math in your head. So 8,844, if I'm rounding it to the greatest place, I know it's either close to 8,000 or 9,000. The digit in the hundreds place tells us to round up. For 4,844, same thing, we're looking at that thousands place for the greatest place. It's bigger than 4,000, not quite 5,000. Look at the digit in the hundreds place. The 8 again tells us to round up. We know that it's closer to 5,000. So once you've rounded both of your numbers, the calculation should be really easy to do. 9,000 minus 5,000. My answer should be close to 4,000. Remember, when you estimate, you give up the accurate answer for work that's quick and easy to do in your head. Estimating products, again with multiplication, follows regular rounding rules. So we're going to round our numbers to the greatest place and then do that easy place value math in our head. So for 6,821, the thousands place is the greatest place, smaller than or larger than 6,000, but smaller than 7,000. That 8 in the hundreds place tells me I need to round up. It's closer to 7,000. Remember, with single digits, they're already rounded to their greatest place, the ones place. So single digits stay the same. So for this problem, for my estimate, I'm going to try to calculate 7,000 times 5. So remember, do that basic problem, do your 7 times 5, and then think about place value. 7,000 times 5 should be 35,000. I want to add on those placeholder zeros. So I know for my original problem, 6,821 times 5, my answer should be close to 35,000. I know the actual answer is going to be a little bit smaller because I rounded up. Estimating quotients was the only time we decided that you can't always use those regular rounding rules. If I tried to use regular rounding rules here and I tried to do 3,000 divided by 7, that's not a problem that I can do quickly and easily in my head. Regular rounding rules don't work with division. With division, you need to use compatibility. So you have to round to a compatible number or a number that's easy to divide in your head. So for this problem, we're doing 3,299 divided by 7. So I know I'm trying to think about a number that's close to 32 that's going to work well with 7. Something that's compatible with 7 that will divide by 7. So if you list out your multiples of 7, you should be able to find one number smaller than yours that's compatible and one number that's greater than yours that's compatible. You want to look for which number is closer to your original number. So I know I was thinking about 32. 32 is 4 away from 28, but only 3 away from 35. So 35 is my closest compatible number. It's divisible by 7, but it's still close to 32. So when you're doing your division, you're rounding your dividend to a compatible number. So 3,299, I'm going to round it to that 3,500. Remember to hold place value in your tens place and your ones place. You started with a 4-digit number close to 3,000. We're rounding it to a 4-digit number that's close to 3,000, but we're rounding to a compatible number. Now I've got an easy problem that I can do in my head. 35 divided by 7 is 5. I know I need to hold place value in my tens and in my ones. So my answer to my original problem, 3,299 divided by 7, should be close to 500. Okay, so that wraps up our video on reviewing whole number place value. See you next time. Bye, kids.